Hello friends, welcome back to my YouTube channel. So in previous video we have seen a problem of non-sway frame. So today we'll see a sway frame problem by using the slope deflection method. How to analyze it we'll see today. So in last video we have seen a problem of non-sway problem. We have done with this problem last video. So I will give link in the description box. You can go through that video. So today we'll see a sway problem. The difference between the sway problem is a little bit of different from the non-sway problem, but non-sway frame problem is similar to the beam. So we have solved the problem on beam also. You can go through those videos if you not seen it. So today we'll see a problem of sway. We'll see a problem of sway frame by using the slope deflection method. How to analyze it, I will the given problem. So the problem is analyze the portal frame loaded as shown in figure by slope deflection method. So this is the given frame. Span AB is having the point load of 8 kN and BC is carrying the UDL of 9 kN and CD is having no load. So the first step is as usual. Step number 1 is to find out the fixed end moment of span AB, BA, BC, CD, etc. So this is our first step. We'll see first step is the find out the fixed end moment of each span. Our span AB is having the point load of 8 kN which is acting at the center. For that we have the formula to find out the fixed end moment. So here we have the formula which is active load is acting at the center. For find outing the fixed end moment we have the formula MFAB is equal to minus WL divided by 8 and MFBA is equal to WL divided by 8. So by using these two formula we will calculate the fixed end moment for span AB as well as BA. So now we will see. So MFAB is equal to, we have the formula minus WL divided by 8. So substitute all the value. So minus load is 8 kilonewton and our length is 3 meter divided by 8. So simplify this, it will come out as minus 3 kilonewton per meter. Similarly for span BA we have the formula MFBA is equal to, the formula is same, only the sign will change here negative and it is because acting anti-clockwise, so it is clockwise. So it will come out as positive 3 kilonewton meter. The answer is same, only sign will change. So similarly for span BC it is carrying the UDL of 9 kilonewton per meter. For the span which is carrying UDL, for that we have the formula MFAB is equal to minus WL square divided by 12 and MFBA is equal to WL square divided by 12. By using these two formula we will calculate the fixed end moment for span BC which is carrying the UDL of 9 kilonewton meter. So MFBC is equal to minus WL square divided by 12. So minus WL square divided by 12. So minus load is 9. So 9, L is 2. So 2 square divided by 12. So by simplifying it will come out as minus 3 kilonewton per meter. Similarly for span CB. So MFCB is equal to, we have the formula WL square divided by 12, only sign will change. So for that the answer will come out in positive, that is 3 kilonewton per meter. And this is for span CB. For span CD, there is no load. It is carrying low load. It means the fixed end moment at span CD as well as DC is equal to 0 because it is carrying no load. It means the moment about the span is CD as well as DC is equal to 0 because it has no load. The span which is carrying no load, the fixed end moment about that span is equal to 0. It becomes 0. So this is our step number 1. It is completed. Similarly, our second step is to find out the slope deflection equation for each span. Our second step is to find out the slope deflection equation. So by using these two formula, we need to calculate the slope deflection equation. So here one more thing is I want to tell you is, so second step is to applying the slope deflection equation for each span. So here the one more thing I want to tell you. So I will redrawn this diagram here. So in case of sway frame, what happens? The vertical member. So here AB and DC are the vertical member. So it will deflect like this. So it will deflect like this in case of sway frame. It will deflect like this. So it means what happens? Deflection is acting at span AB and CD. So deflection is not act on the horizontal member, that is BC. So it only act on the vertical member, that is BA as well as DC. The deflection is acting at vertical member. So the deflection is always act on vertical member. So here AB and DC are the vertical member. So our deflection does not act on the horizontal member. So it means what we have to do is, here the vertical member are BA and DC are the vertical member. For calculation of the moment, we have to take the 3 delta divided by L. So while calculating, we need to take this 3 dou divided by L for vertical member. Here BA and DC are the vertical member. So while calculating, we need to take this 3 dou divided by L. So for calculating the BC, we should not take 3 dou divided by L because it is the horizontal member. So deflection is not act on the horizontal member. So while calculating the BC as well as CB, we should not consider the 3 dou divided by L. So we need to consider this only while calculating the vertical member. So here BA and DC are the, so we need to take the 3 dou divided by L only for the vertical member. So while solving, I will let you know how to calculate this. We'll see step by step procedure. So now we'll see for span AB, or AB is the vertical member. So for that we need to use this formula. So now we'll see. So our MAB is equal to MFAB plus 2EI divided by L, 2 into theta A plus theta B minus, we need to take the 3 dou divided by L. So now substitute all the values. So MFAB value we got was minus 3. So substitute that value. So minus 3 plus 2 into EI. To EI value is given here 2i. For span AB it is 2i. So 2 into E, I value is 2i divided by, so length is 3 meter. 2 into theta A. See here, theta A is the fixed end. At fixed end there is no slope. So it becomes 0. 2 into 0 is the 0. So I am not putting that. So theta B is it has some value. So keep it as it is. Theta B minus 3 into dou divided by, our length is 3 meter. So substitute that. So by simplifying, it will come out as -3 plus 1.33 EI theta B minus 1.33 EI delta. So call it as equation number 1. So similarly we need to calculate for span BA. So we need to calculate for span BA. So for that we have the formula. So MBA is equal to, so we need to substitute this formula in case of same, we need to put this formula. So MFBA plus 2EI divided by 2EI divided by L 2 into theta B plus theta A minus 3 rho by L, because it is the vertical. We need to take the 3 rho divided by L for vertical members. So now substitute all the value. MFBA value we got was 3. So 3 plus 2 into E, I value is 2. They gave 2. So 2I divided by, so our length of span BA is 3 meter. So 3, 2 into theta B, it has some value, so keep it as it is, and theta A is the fixed end, so it becomes 0. So I am not writing it. Minus 3 into delta divided by length is 3 meter. Substitute. So simplify this. So by simplifying it will come out as MBA is equal to 3 plus 2.67 EI theta B minus 1.33 EI delta. So call it as the equation number 2. So similarly we need to calculate the for span BC as well as CB. So now we'll see our span BC is the horizontal member. We should not take the 3 rho divided by L because the deflection is not acting on the horizontal member. That's why we should not consider the 3 rho divided by L. So now we'll see how to calculate this. For span MBC, so we have the formula. In case of AB, we need to substitute BC. So MFBC plus 2EI divided by L, 2 into first alphabet is B plus theta, second alphabet C. So you should not take the 3 rho divided by L because the deflection is not acting at the horizontal member. So substitute all the value. MABC value we got was minus 3. Substitute this value there. 3 minus 3 plus 2E. So I value for span BC is I. Substitute this value in our equation. Divided by length is 2 meter. So length of BC is 2 meter. They give, substitute this value. Plus 2 into theta B has some value and theta C also some value. Keep it as it is. Now simplify this. So our MBC will come out as minus 3 plus 2 EI theta B plus EI theta C. So call it as equation number 3. Similarly for MCB, span MCB we need to calculate. So for that we have the formula, this one. In case of BA we need to put the CB. So MCB is equal to MFCB plus 2EI divided by L. 2 into first letter is theta C plus second letter is theta B. So minus 3i by minus 3 delta divided by L we should not take because our BC is the horizontal member. So substitute all the value. MFCB value we got was how much? So MFCB we got was 3. Substitute this value there. 3 plus 2 EI value is I divided by length is 2 and 2 into theta c it has some value, keep it as it is. Theta b also it has some value, keep it as it is. So now simplify this, it will come out as MCB is equal to 3 plus EI theta b plus 2 EI theta c. Call it as equation number 4. So now we need to calculate the for span CD as well as DC. We need to go for span CD as well as DC. So now first we'll see for span CD. For that we need to use the MCD is equal to, in case of AB we need to substitute the CD value. So MF CD plus 2EI divided by L, 2 into first letter is C plus second is D, theta D minus here the vertical. So our CD is the vertical member, so we need to consider 3 rho divided by L. So 3 rho divided by L because it is the vertical member. Deflection is acting on vertical member. So now substitute all the values. So MFCD value we got was, so MFCD value we got was 0 because there is no load acting on this span. So value becomes 0. Put this value there. 0 plus 2 into E. So our I value is, for CD span I value is 1.5i. So put this value there. 1.5i divided by length is 2 meter. So put this value there. 2 plus 2 into theta c also has some value. Theta d is the fixed end. See here our point D it has a fixed end. So at fixed end our slope value becomes 0. So put theta d is the 0. So I am not writing it. So 3 into dou divided by length is 2. So substitute this, the value will come out as MCD is equal to 3 EI theta C minus 2.25 EI delta. Call it as equation number 5. Similarly for MDC we need to calculate. For that we have the formula. We need to put this one. In case of BA we need to substitute DC value. So now we'll see. MDC is equal to MFDC plus 2EI divided by L. 2 into first letter is D. So theta D plus second is C. Theta C minus 3 rho divided by L because it is the vertical member. The deflection is acting on it. We need to take 3 rho divided by L. Substitute all the value. MFDC value we got was 0 because there is no loading acting at span DC. So that's why our MFDC value becomes 0. So put this value there. And here the I value is 1.5i and length is 2 meter. I am directly substituting this value in the equation. Substitute all the value. MFDC value is 0 plus 2 into E into 2 into E. I value is 1.5i divided by length is 2. 2 into delta C and theta D is the fixed end. The value becomes 0. Directly I am putting as 0. Theta C it has some value, so keep it as it is. Minus 3 rho divided by length is 2 meters. So put that value. So by simplifying it will come out as MDC is equal to 1.5 EI theta C minus 2.25 EI delta. So call it as equation number 6. So this is our second step. So now we have calculated the moment for the all the span. So here the difference is only we need to take the 3 rho divided by L for vertical members. We should not consider the 3 rho divided by L for horizontal members, because at horizontal member deflection is not acting. So it will act only on the vertical members. That's why we need to consider the 3 rho divided by L only for calculating the vertical members. So this is the different for our second step while calculating the slope deflection equation. So now we'll move to the step number 3 is the calculation of the equilibrium conditions. We need to apply this. So now we need to apply the equilibrium conditions. So it acts only at the joints. So for our problem we got the two joints, joint B as well as joint C. So this is our problem. So applying the condition of equilibrium. So where it comes? It comes on the joint. So here in our problem we got the two joint B as well as joint C. So for joint B we have the equilibrium condition MBA plus MBC is equal to 0. So we need to take the left moment and right side moment of the joint. So for joint P we have the moment MBC and plus MBA is equal to 0. And similarly for joint C we need to take the left side moment as well as right side moment. For our joint C we have the equilibrium condition MCB plus MCD is equal to 0. So I will show here. For joint B, we have our equilibrium condition MBA plus MBC is equal to 0. For joint C, we have the equilibrium condition MCB plus MCD is equal to 0. So call it as 1 equation. This is the 2. We need to apply these two condition. So one more will come, I will tell you later. By first we'll solve these two conditions. So after that I will show you one more condition will exist in this third step. I will show later after calculating this. So for joint P we have the equilibrium condition MBA plus MBC is equal to 0. So substitute MBA as well as MBC value in this equation. So our MBA value we got was MBA is equal to 3 plus 2.67 EI theta B minus 1.33 EI delta. So substitute this value in that equation. And MBC value we got was minus 3 plus 2 EI theta B plus EI theta C. So substitute these two values in this equation. So our MBA value we got was 3 plus 2.67 EI theta B minus 1.33 EI delta minus our MBC value we got was minus 3 plus 2 EI theta B plus EI theta C is equal to 0. So now simplify this, it will come out as 4.67 EI theta B. Here plus 3 minus will get cancelled. 2.67 EI theta B plus 2 EI theta B, it becomes 4.67 EI theta B. So minus EI theta C minus 1.33 EI delta. Keep it as it is equal to 0. So call it as equation number 1. So now we will apply the second condition. So this is our second condition. MCB plus MCD is equal to 0. So now substitute MCB and MDC value in this equation. MCB value we got was 3 plus EI theta B plus EI theta C, and MCD value we got was 3 EI theta c minus 2.25 ei delta. So substitute these two value in our equation. So our MCB value is 3 plus ei theta b plus 2 ei theta c plus 3 ei theta c minus 2.25 ei delta is equal to 0. So now simplify this, it will come out as ei theta b plus 5.0 ei theta c minus 2.25 ei delta. Ei delta is equal to plus 3 is there. Here we need to take this to right side, it becomes minus 3. So call it as equation number 2. So this is our equation number 1 as well as this is equation number 2. So now here one more step will come, I will show. So here we have to draw the vertical member as it is. So after that, the first thing what we have to do is apply the loading whatever they are given. So here 8 kilonewton they give, I am writing here, so I have written here. So this is our vertical members I have drawn here. So first thing what we have to do is apply the moments. So at point A the moment will be MAB. So at point B, so here the moment is MBA takes place. So at point C, here also the moment about point C is MCD. So at point D, the moment about point D is MDC. So all are clockwise, moving clockwise. So after applying the moment, our second step is to apply here one at point A the reaction will takes place horizontal. At point D also one reaction takes place. So call it as at point A HA, horizontal reaction. At point D HD. So horizontal reaction at point D is called as HD. So we always take the positive. So the forces which are moving in this direction taken as positive and which are moving in this direction taken as negative. So I am taking the positive reactions because we have taken the movements clockwise. Positive movements we have taken, for that we need to take the positive reactions. So I have taken H and HD. So this is our second thing we have to do after drawing the vertical members diagram. So now what we have to take, we need to calculate the separately by taking this member as well as taking this member. So now we will see the for member AB. So we need to take the moment about point B. So we need to take the moment about point T. For that, summation of MB moment about B is equal to 0. Clockwise we need to take positive. So C only this member will calculate separately for this member. So hide it, take this member. So moment about B, it means the whatever the moments are coming here, MAB is moving clockwise, so we need to take the positive. So that is MBA. So this is MBA. So MBA is moving clockwise, so I have taken positive. So MAB also moving clockwise, we need to take, that is plus MAB. So here the one horizontal load is acting. So if you rotate, it will act like this, it will move anti-clockwise. So I will show you. If you turn this, so here HA will move like this anti-clockwise. So we need to take the minus HA. Minus HA into the distance from here to here. The minus HA into the distance from here to here is 3 meter. So we need to take into 3. So the one more reaction is horizontal reaction is acting, that is point load 8 kilonewton at a distance of 3 meter. If you rotate this, it will move like this anti-clockwise. So I am again taking minus 8 into at a distance of from here to here is 1.5. At a distance of 1.5 it is acting is equal to 0. So now simplify this. So by simplifying, our answer will come out as HA is equal to MAB plus MBA minus 12 divided by 3. So call it as equation number 1. So this is for span AB. So now similarly we'll calculate the span CD by taking the moment about point C. We need to calculate for this member also. For that I am taking summation of moment about C is equal to 0 clockwise positive. So here MCD is moving clockwise. So MCD plus MDC is also moving clockwise. MDC. So only two moments are acting. Here the one more reaction is acting, so that is HD. So if we turn like this, it will move anti-clockwise like this. So minus HD into at a distance of from here to here is 2 into 2 is equal to 0. So now simplify this. So our HD will come out as MCD plus MDC divided by 2 is equal 2. So call it as equation number 2. So this is our HA and this is our HD. So now we got the HA and HD value. So now what we have to do is, the one more thing is, so now we are calculating the horizontal equilibrium. So horizontal equilibrium means we need to take the summation of all the horizontal, summation of fx is equal to 0. We need to do this. Summation of all the horizontal forces is equal to 0. So for here the only we need to take the horizontal loads whatever they are given. Summation of fx is equal to 0. Here HA is horizontal, so we need to take HA plus here HD is there, it is also horizontal. We need to add only horizontal forces. Here one more load is point load is acting horizontally, so that is 8 kilonewton is equal to 8 plus 8 is equal to 0. So see, is there any horizontal reactions are taking? No, only HA, HD and here on point load is acting horizontally. So we need to add all the horizontal reactions. So now substitute the HA and HD value we got. So whatever we got HA and HD, we need to put this value in this equation to simplify. So our HA value we got was MAB plus MBA minus 12 divided by 3 plus HD value we got was MCD plus MDC divided by 2 plus 8 is equal to 0. So by simplifying, the answer will come out as, the final answer will come out as 1.33. So first we need to substitute our MA, AB, MBA will all the value I will substitute. So our MAB value is minus 3 plus 1.33 EI theta B minus 1.33 EI delta plus 3 plus 2.67. Whatever we got, we need to substitute all the values, not all the values. So MAB and MBA value 2.67 EI theta B. So EI theta B minus 1.33 EI delta minus 12 is there, keep it as it is. So divided by 3 is there. So divided by 3 is there. Divided by 3 plus, I am writing here, MCD value we got was 3 EI delta C minus 2.25 EI delta plus MDC value we got was 1.5 EI theta C minus 2.25 EI delta divided by 2 is there, so keep it as it is, divided by 2. So plus 8 is there here, plus 8 is equal to 0. So now make it separate and simplify this. So the final answer after simplifying will get, I will show. So simplify this, the final answer will come out as 1.33 EI theta B plus 2.25 EI theta C minus 3.1366 EI delta is equal to minus 4. Call it as equation number 3. So simplify this. I will show simplify version of this way. So if you simplify this, the answer will come out as, so this is the final answer. So if you simplify this equation, the answer will, this is the simplified version of this. So the final answer will be 1.33 EI theta B plus 2.25 EI theta C minus 3.1366 EI delta is equal to minus 4. So I have written here the direct answer. So if you want, you can take this. So now we'll see. So now what we have to do, the solve the equation number 1, equation number 2 as well as equation number 3 to get the EI theta B, EI theta C as well as EI delta value. So we need to solve these 3 equations. Now I will show how to solve this. Mod equation number 5, and here we need to take the 2 because we have 3 equations, no? So I will show again. So wait, mod equation number 5, we need to choose the second option because we have the 3 equations, no? That's why. So our first equation is this one. So here equation number 1, here EI theta C is positive, so here make it as positive. So now substitute all the values. So our equation number value is 4.67 plus 1 minus 1.33 is equal to 0. Equation number 2 is EI theta B 1 plus 5.0 plus is equal to minus 2.25. So minus 2.25 is equal to minus 3 is there. So minus 3. So now equation number 3
so now
is,
substitute equation number 3 is
1.33 EI theta B. So 1.33 is equal to 2.25. 2.25
is equal to
minus 3.13 minus 3.1366 is equal to minus 4 is there. So minus 4 is equal to,
so now simplify
so solve it.
It will come
So
out as,
x value is nothing but EI theta B. So it come out as 0.41.
So EI
So
theta B
now
value
write
is
it.
0.41.
I am writing here 0.41.
0.41.
So now solve it for
So now solve for
EI
the
theta C
second
value.
time.
It
The
come
y
out
value is
nothing but EI theta C value. It come out as minus 0.04 is nothing but our EI theta C value. Now solve it for one more time. So Z value is nothing but EI delta value. It came 1.41. So now we got the EI theta B, EI theta C and
EI delta value. So now what we have to do is substitute EI theta B, EI theta C and EI delta value in equation number 1, 2, 3, 4, 5, 6 to get the final moments. So step 4 is to find out the final moment. So to find out the final moment, I have written here all the equations. So now we will solve one by one. So our MAB is equal to minus 3. So minus 3 plus 1.33 EI theta B value we got was 0.41 minus 1.33 EI delta value we got was 1.41. So simplify it, it will come out as minus 4.33 kilonewton meter is nothing but our MAB value. So next MBA. So 3 plus 2.67 EI theta B value we got was 0.41 minus 1.33 EI delta value we got was 1.41. Put it here 1.41. By simplifying it will come out as 2.21 kilonewton meter. Similarly MBC is equal to minus 3 plus 2 EI theta B value is 0.41 plus EI theta C value we got was minus 0.04. So by simplifying it will come out as minus 2.22 kilonewton meter. So now similarly for MCB is equal to 3 plus EI theta B value we got was 0.41 plus 2 EI theta C value we got was minus 0.04. By simplifying it will come out as 3.33 kilonewton meter is our MCB value. So now our MCD is equal to 3 EI theta C value is minus 0.04 minus 2.25 EI delta value we got was 1.41. So 1.41, simplify it, it will come out as minus 3.29 kilonewton meter. So now MCD is equal to 1.5 EI theta C value is minus 0.04 minus 2.25 EI delta value we got was 1.41. By simplifying it will come out as minus 3.23 kilonewton meter. So these are the final moments value we got. So our next step is to drawing up the bending moment diagram. So I have already drawn the pre-body diagram of the bending moment. So point AB is carrying the point load of 8 kilonewton. To find out this maximum height we have the formula WL divided by 4. So here W is 8 kilonewton and length is L is 3 meter. Put this value in this formula. So by simplifying it will come out as 6. So BC is carrying the UDL. To find out this maximum height we have the formula WL square divided by 8. Here W is 9 and length is 2 meter. Put this value in that equation. So by simplifying it will come out as 4.5. So now we will go for the net bending moment diagram. By using this final moments value we will draw the net bending moment diagram of this. So before this I want to tell you something. So to draw the net bending moment diagram, so see here our MAB value we got was minus 4.33. So here our first point is A. So at point A the negative value is coming. So make it as it's positive and it is negative. So at point A negative value is coming above the neutral axis. So it means it comes here. So our value is minus 4.33. It means it comes here. Minus 4.33 it comes here. And similarly our MBA here first point is B, at point B 2.21. So at point B positive value comes above the neutral axis. It means it comes here 2.21. It comes here above the neutral axis. So similarly MBC here first point is B, here minus 2.22. So at point B negative value is coming above the neutral axis. So it comes here And similarly for MCB, the value is 3.33. It is positive at point C. The positive value comes above the neutral axis. It means it comes here. So 3.33 it comes here. And our MCD value first point is C, minus 3.29 at point C. So your first point is C, at point C negative value is coming. So negative value is coming below the neutral axis. So it means it comes below the neutral axis, means it comes here, minus 3.29 comes here. And for MDC, here first point is D. So at point D negative value is coming above the neutral axis here. So minus 3.23 is coming here, it comes here. So now join all these lines to get the net bending moment diagram. So join it. So it will come like this, and again join this. So this is our net bending moment diagram. So carefully join all the lines. So this is our net bending moment diagram. So net bending moment diagram of this problem. So if you want, you can write down all the values here. Here 2 point. So 4.33, sorry, 4.33, and our MBA value is 2.21, and here 3.33, and here also minus 3.29. So you can write down all the values. If you want, you can write down. So this is our net bending moment diagram. This is negative, here also negative. And so if you like the video, like it, share it, and subscribe for the more videos. Thank you for watching.